All right, today we are learning something about something called inverse functions. And an inverse function, this is our first definition on our note sheet, is a function that undoes the action of the original function. So if we think about inverses, we're kind of thinking, all right, when I have plus, the inverse is minus. When I have multiply, the inverse is divide. When I'm squaring something, the inverse is taking the square root of that thing. So we're thinking about undoing the actions, doing the opposite, doing the inverse. Two things to kind of point out here is, one thing to point out is the notation. If this f of x is the original function, then we're going to call the inverse is just going to be f to the negative 1 power. And that's just a symbol that kind of notates that we're dealing with inverses there. So let's kind of see how this plays out so we can get a better idea of what's going on. On your note sheet, you'll notice kind of 4 steps here: changing f of x to y, switching x and y in the equation, solving for y, and changing y to f of negative 1. So steps 1, 2, 3, and 4, or sorry, 1, 3, and 4, these are kind of just housekeeping steps. They're going to be really easy for us to carry out. Where step 2 is going to be the one that we have to do. Oh, sorry. Let me say that. Step 1, 2, and 4 are housekeeping items, whereas step 3 is the one that we're going to have to do a lot of the work with and harness our algebra skills. So let's kind of walk through this. First thing I'm going to do in this equation, for example 1, is I'm going to change my f of x to y. And this is just really a housekeeping item. We got y equals x plus 3. The reason we're doing it is we don't want to rewrite f of x over and over and over again. Then step 2 is probably the most important conceptually to what's going on. We want to switch out x and y in the equation, and all we're doing is rewriting it with x in the place of y and y in the place of x. That is where we get our inverse. That allows us to undo everything. By flipping that input and output, we can create a situation where we have our inverse. Then we go through and we're going to start solving for y. So that means I'm trying to get y all by itself. And to do that, it looks like it's with this plus 3 right now. I'm going to subtract 3 from both sides to move that over. And I'll get x minus 3 equals left over with just y now. So now that y is isolated, and that last thing we're going to do is change our y to our inverse setup. So if we go x minus 3 equals that inverse f to the negative 1 of x. And normally what we want to do is write this in the other direction. You can do this in one step if you want to as well. Our inverse is equal to x minus 3. And you'll notice here with this equation, we could have probably predicted it. If our original is doing x plus 3, then our inverse is going to subtract that 3, right? That's our inverse operation. This is a kind of easy example to build up the steps. We'll kind of repeat it with another one, and then start to hit some more difficult ones where you will kind of have to rely on these algebra skills. So in example 2, you'll notice that it says g of x here instead of f of x. That just really goes for any function. We can do the exact same thing. I'm going to start by changing that to y. So I go y equals 2x. Then I'm going to do that important step of switching x and y in the equation. X is equal to 2y. Now I'm on the difficult step of solving for y. In this case, since 2 and y are being multiplied together, we can divide on both sides, giving us x over 2 equals y. And then finally, we can just change that y to our inverse notation, and I'm going to rewrite it left to right as well. Inverse of x is equal to x over 2. And again, check out that jump between we had multiply up here and we had divide down here. We are finding those inverse operations. So we're going to start seeing some more complicated examples. Now there's multiple things going on. In example 3, you'll notice that we have a multiply with our 4. We have an add with our 8. So as I work through, I should expect at some point I am going to subtract. and at some point I'm going to divide, right? We can kind of make those predictions as we go and be on the lookout for it to see what makes sense. So working through my process, first thing I'm going to do is those housekeeping items. Going to go y equals 4x plus 8. And then I'm going to switch that x and y in the equation. X equals 4y plus 8. Once I do that, then I can do the difficult step of getting y all by itself. So now I'm going to subtract 8 from both sides. This is just like our solving steps with our algebra, especially with linear equations. We get x minus 8 equals 4y. And then I need to divide both sides by 4. And it's important that we divide the entire left side by 4. We can't just divide the certain parts. We need to divide the entire left side by 4. We'll get x minus 8 over 4 equals y. And then we'll do that final step of switching our notation up, our inverse. Oh, and in this case, it's an h. Make sure we grab that. That's important there. H of x is equal to x minus 8 over 4. Okay, definitely start trying this on your own. Pause your screen, unpause it, check against my work. I'm going to buzz through example 4 now as well. We have 8x minus 4, so I'm going to do my housekeeping. Y equals 8x minus 4. Switch that up to x and y, so x equals 8y minus 4. Then I can start doing my algebra, add 4 to both sides. X plus 4 equals 8y. And then lastly, dividing by 8 on both sides to get that y all by itself. And then we get x plus 4 over 8 equals y. Geez, I got to write my y's better. And lastly, just kind of declaring that as the answer here, our inverse of x is equal to x plus 4 over 8. Now, there's no way we're going to be able to see all of our different options today, but I'm going to kind of try to make sure you get exposure to a bunch of different ones. Now we have some instances where we're dividing numbers, so we got to kind of work a little differently to get through those. In example 5 and 6, we're going to actually have to do our first step with multiplying because we have a division going on. But let's just kind of do our housekeeping on example 5. Y equals x minus 2 over 6, and then let's switch up those x and y components. X equals y minus 2 over 6. Now, since the entire equation is being divided by 6 first, before we subtract, we need to multiply by 6 on both sides in order to get rid of that fraction, that denominator there. So we're left with 6x equals y minus 2 after we do that. And then we can add 2 to both sides to finish out the problem and get 6x plus 2 equals y. And I'll just rewrite this with our inverse notation. So our inverse is equal to 6x plus 2. Now, again, you could probably made that prediction that, hey, since we have a minus 2 going on, we are going to add 2 at some point. And since we have divide by 6 going on, we are going to multiply by 6 at another point in our equation. It's important to still go through the algebra to make sure you do those in the right order, but you can make definite predictions there on what's going on. So example 6, we have y equals x plus 3 over 9. Now I'm going to switch that input and output, so I get x equals y plus 3 over 9. I'm going to go ahead and start solving that or isolating it for y. So multiplying by 9 on both sides. Okay, get 9x equals y plus 3. And lastly, subtracting 3 on both sides, giving me 9x minus 3 equals y. So I'll just rewrite our function notation. 9x minus 3. right, so most of you are going to hang out with these simpler equations today, but for those of you who are ready for it and for tomorrow's lesson, we definitely want to start pushing into more advanced equations where we got maybe some square roots, some squares going on. The bulk of this is just going to start kind of the same way as our previous problems, right? We're going to do those kind of housekeeping items. So y equals the square root of x minus 5. And then let's make sure we switch up those x and y's, switch up those inputs and outputs. X equals square root of y minus 5. Then to undo a square root, we need to square it. We learned about that earlier. So x squared equals the square root of y minus 5 squared. That gets rid of that there. So we just get x squared equals y minus 5. And then I can go ahead and add 5 to both sides. To get that y all by itself, we get x squared plus 5 equals y. And then I'll just rewrite in our function notation, our inverse of g is equal to x squared plus 5. Now, in example 8, let's set it up just like we always would. Y equals x squared plus 6. Then x equals y squared plus 6. Let's move that 6 over before we try to get rid of that square and handle it that way. So now we get x minus 6 equals y squared. And what we do here to kind of undo a square is we will take the square root of both sides, right? So we'll go square root of x minus 6 equals the square root of y squared. But it's important when we do that we take both the positive version and the negative version, right? Because we can do 4 squared to get 16, but we can also do negative 4 squared to get 16. So if we're going in that reverse direction, we need to take into account that this can be a positive or a negative square root. So that gets covered by this plus minus sign here. And if we kind of just finish that out, then we have the plus minus square root of x minus 6 equals square rooting a square, just cancels it out, so equals y. And finally, I'll just write this in our inverse notation. Our inverse of f equals plus or minus the square root of x minus 6.